Looking at what makes something linear versus quadratic, and it has to do with the exponent 2 being there. So we're talking about things that have x squared. Your standard form of a quadratic equation is y equals ax squared plus bx plus c. So a is the coefficient here, and b is the coefficient on x, c is the constant at the end. And the awesome quadratic formula, we hope you remember from years past. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to break this apart today and look at the part at the top. So there's some definitions in here, and this word discriminant is just the part that's underneath the radical. So we're going to get information about our answers by looking at what kind of answer we get underneath. So we need to remember what these different kinds of numbers are. Perfect squares, things like 0, 1, 4, 9, 25, oops, 16 I'll throw in there, 25, 36, etc. Perfect squares. Rational numbers, I want you to look at that root word, ratio. Anything that can be written cleanly. So it could be like a 7 or a 4. It could be like a 1/2. It could be like a 5/3. Anything that has a ability to be written as a ratio or fraction is rational. So what's irrational? Those are ugly square roots. And even if it has part nice, part ugly, like a root 20, even though 4 is in there, the square root of 20 is irrational. Now imaginary numbers are going to come out when we do radicals and we end up having negatives underneath. Because remember, we're talking about what's coming underneath the radical. Even if it's a clean number, it's going to be imaginary as long as it's negative. So let's see if we work with discriminant. And remember, the discriminant itself is just b squared minus 4ac, the part under the radical. If your discriminant came out to be 49, that's a really clean, nice number. That would mean your answer would be real and rational. If it's negative, clean or ugly, your answer is going to be imaginary. Once there's a negative, you're going to be imaginary. 15, not the pretty kind, so that's going to be irrational. Can't write that as a pretty number. Square root of negative 16. Now, square root of 16 is nice, but the negative overrides it. That's going to be your imaginary. And then the next one, I'm looking at 4. Really clean, pretty number, like 49 was. So that's rational. So the prettier it is, the rational is your answer. 20, again, that's going to be more like the 15. That's going to be irrational. So part of what we're going to be doing in the problems is dealing with vocabulary. And sometimes that's tough. The other thing we're going to play around with is simplifying. And we should be able to simplify fractions, but we find people always struggle with this. So a couple things going on. First, we have to be able to clean up a radical. So if I have a square root of 12, I'm going to pull out the 2i. And we need to remember, when you have two parts on top, the bottom, the denominator, belongs with both parts. So instead of writing it as the big fraction here, I could write that as negative 2 plus or minus I root 3. And then the one over here on the right, it's pretty, and so I have a square root of 49, which is 7. You can actually work this one out, and you can say, hey, what's 3 plus 7 over 4? That's 10 over 4, or 5/2. What's 3 minus 7 over 4? That's negative 4 over 4, or negative 1. So if, again, you have a clean number, you're going to have a rational answer. That's what a rational answer looks like. It can be written as a ratio. So let's dive into what it looks like when we're actually doing the quadratic formula. You have this big equation here, and if you look at the values, a is 1, b is 8, and c is negative 6. So I'm going to say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I need to substitute those numbers in. So I'll have negative b plus or minus the square root, b squared minus 4ac all over 2a. And this is where I have to work on cleaning things up. What I have happening under here is I have 64 plus 64, otherwise known as 64 times 2. I'm just going to remind you of that. So underneath the radical, if you know part of it's clean, because I know what the square root of 64 is, we want to pull that part out. And so what I'm trying to simplify is negative 8 over 2, and then the square root 8 root 2 over 2. Final answer cleaned up would be negative 4 plus or minus 4 root 2. That's me just reducing. So what's all the stuff with the discriminant? The discriminant is looking at this number here. And when I had 64 plus 64, that was 128, which was not a perfect square. So it's real, but irrational. Irrational because it's not a clean perfect square here. These next two are kind of interesting. If you look at number 2, there's no x value, and what it means is b is 0. So when I try to set up my equation, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and I start substituting values in, I'm going to have a 0 every place there's a b. 0 squared is 0. Minus 4ac, well, that's kind of long under there, all over 2a. Now I want you to look at what's happening in here. This is a positive 100, and so what I really have happening is the square root of 100 with a plus or minus all over 2. 10 over 2 is what we're simplifying, so my answers are plus and minus 5. The discriminant again is this part underneath. Because it was a clean 100, I knew that my answers were going to be real, and this time rational, right? Rational. I can write 5 as a ratio. When I look at the second one, you've got to be alert that it has to be set equal to 0 before you can dive into substituting, because you have to know that the c value would be a positive 12. So I like to set up the big area where I'm going to put my substitution in, and now I'm going to go take my values. And I'll say x equals negative b, so that's positive 7, plus or minus the square root of b squared, 7 squared is 49, minus 4ac all over 2a. And while it looks kind of scary under there, that's really just 49 minus 48, otherwise known as 1. So I think 1 is a comfortable discriminant. Remember, this number under here is just 1. 1, like 100, is a perfect square, so my nature of my roots, like what are the roots going to look like? What are the answers going to feel like? They're going to be rational. So I'll finish it up by saying, okay, I have 7 plus 1 over 2, otherwise known as 4, and I have 7 minus 1 over 2. 6 over 2 is 3. So when you're looking at all these examples, I want you to make sure that the discriminant is just the part underneath. So we'll just jump in and look at this. The discriminant is just this part right here, 121. That's clean. You're going to have nice answers. The discriminant here is the 8. That's not a clean square root, so I'll have irrational. This discriminant here is 17, not a clean square root, so irrational. When you're saying irrational, expect to have those ugly square roots in there. But there's one thing we haven't seen yet. It's on its way. So don't panic, but here it comes. I'm looking at what's going to happen on this last problem. I'm going to substitute my values in to my big quadratic formula. I'm going to say x equals negative b plus or minus the square root of b squared, 2 squared is 4, minus 4ac all over 2a. And when I work this out under here, 4 minus 8, what? I'm getting a negative underneath. So I have negative 2 over 2 plus or minus the square root of negative 4 over 2. But we know what that is. That's 2i. So if I'm trying to clean this up, while it looks kind of crazy looking, my answer is 1 plus or minus I. Now, that has an I in it, so think about what you know. It means because the discriminant was negative, my answer is imaginary. It should have I in it, and guess what? It does. All right, happy solving.